All right, so we can start.
Okay, guys. Can you see my screen? Okay, let
Not
me.
yet.
No, we can't see your screen.
Oh, guys, I'm coming.
Okay.
Can you see my screen?
Yes.
Yeah.
Yes, we do see your screen.
Okay. So, hi everybody. So today in this tutorial, we're gonna cover hypothesis testing. So you guys know that, like, for example, in business, there are so many decisions that have to be taken. So instead of just taking them like that, doing some experiments and create some hypotheses is more data-centric approach for doing business. So basically, hypothesis testing is just a way of taking decision in inferential statistics. So in hypothesis testing, it reflects the scientific methods adapted to the setting of research involving data analysis. So in this framework, the researcher makes a precise statement about the population of interest and then aims to falsify the statement. And the statement in question is what we call the null hypothesis. So, like, you are doing some experiment, you make some statements, that is the null hypothesis, and your aim is like to verify, to try to see if you can falsify or not the statement. So basically, hypothesis testing has two attributes. We have the null hypothesis and the alternative hypothesis. So in this tutorial, we are going to see, like, what are the different types of, some of the different types of hypothesis testing, and some cases where we generally use hypothesis testing. And here you can see that from here, we have some cases that we are usually using hypothesis testing are one population proportions, difference in population proportions, one sample mean, difference in population mean. So let me just explain this briefly. So when I say one population mean, what does it mean? For example, I have a population and I've drawn a sample from the population. And the idea is that I want to see if really statistically my sample has the same distribution as my population. So what do? I just compute the mean of the population. You can compute as well the mean of the sample. And probably the two means are closer. But we don't know statistically if those two means are the same. So what I'm doing is I just perform a statistical testing, hypothesis testing, to see if the mean of my sample is the same as the mean of the population. And from there, I can say, like, my sample has the same distribution as the population. And that one, you have to note that, like, I only have one population, and from the same population, I have drawn a sample of sample data. So the difference in population mean, that means that I have two different samples separately, and I want to know if the two samples maybe have the same distributions, or the two samples have the same mean. So that's why we said difference in population means. So, like, I have two different samples, completely different. The first one, like, we have one population and we drawn the sample from that population. But here we have two different groups, and we want to see if the two groups have the same mean, or they have maybe the same distribution, something like that. So we are going to cover, throughout this tutorial, we are going to cover some of these cases. So the hypothesis testing, we have what we call the Ttest, and basically this is the formula of the Ttest. What it does is that we have the best estimate minus the hypothesized estimate and divided by the standard error of the estimate. And then when we compute the test, it comes with something that we call a p-value. And based on the p-value, we can know whether we have to accept our null hypothesis or we have to reject the null hypothesis. And you guys should note that in hypothesis testing, we have like two types of errors. What do I mean? Sometimes like we have type 1 error and type 2 error. Type 1 error occurs when the null hypothesis is true but is incorrectly rejected. It happens, right? Maybe you might reject the null hypothesis but it was true. Or the type 2 error occurs when the null hypothesis is not rejected but it actually is false. So these are some errors that involves hypothesis testing. But statistically, there are some ways to handle these types of errors, but I did not cover them in this tutorial, just to give you like the basic understanding of the two types of errors that we have in hypothesis testing. So basically in this tutorial, I'm just gonna cover two hypothesis testing types, what we call the Z-test and the T-test and the Z-test. And each of them, for T-test, we have one sample T-test and two sample T-tests that I will come back later. So what is the T-test? The T-test just tries to compare two average means or maybe proportion and tells you if they are different from each other or not. As I give you the example, like I have my population, I compute the mean of my population, I have my sample, I compute the mean of my sample. But statistically, I want to know if really the sample has the same distribution as the population, or the sample has the same mean as the population. So this is like basically what is T-test. And in one sample T-test, this is what I've explained. Like you have one population only, and your sample is from the population. And you try to check out if the population mean is the same as the population sample statistically, not just to compute it like that. You might compute them like that. You may realize that they are not really far from each other, but statistically they might not be the same, and that means that they might not just come from the same distribution. They might not have the same distribution. So that is one sample statistic. We have a population and we draw a sample from the population and we perform our hypothesis testing using the statistics. So let us just do some examples. Here I have created some variables. So like age data for the population of voters in an entire country. Let me say like in Senegal, for example, my country. So this is an age data for the entire country of Senegal. And I have a sample of voters in Dakar, the capital. So this is just a sample of voters in Dakar. So the idea is that like I want to test whether the average age of the voters in Dakar differs from the population, like the entire population in the country. So let's start. Here I have imported some couple of libraries that we use throughout these tutorials. So okay, this command line like is just like it allows me to not have every time I run these random numbers like to have like different things, because I'm generating random numbers using like Poisson distribution. So this, if I run this, I can run it many times, but I still have the same because I already have this. I fix it. You can put any number you want here. It is not just you have to put 6 or something like that. You can just put anything you want, just a number. So the population age one, like simulated from the Poisson distribution by specifying these parameters, and the size is this, like 150,000. And here I have the same, like, but I just change this mu with the same size, and I have concatenated these two data that I have one data, and I call it the population age. So this is my population age, you see. And here I have the sample for the population, the sample age data for Dakar. So the same thing using the same Poisson distribution, for example, with different parameters. Here I have like mu 30 and mu here 10, but the sample, since it's the sample, it cannot be like the same size as the population. I just have taken here 30 and 20, and I have combined these two data, and this is my age data for Dakar. So see, when I compute the mean of these two, this is the mean of the two data that I have, the population and my sample. I have this. Okay, someone might say they are not really far, or someone might say they are not different. 43 and 39, they are not the same. So, but we are not sure. Statistically, what we think might not be the truth. So, let's do some hypothesis testing. So, here we conduct a hypothesis testing using this function start.test underscore one sample. That means that I'm doing one sample t-test, start.ttest underscore one sample. And what I have to put inside the function as argument, here I have to put my sample first and the population mean. You could have just write this directly, the mean of my population, which is here. But let me just do this. The first argument is just my sample, and the second argument is the population, the mean of my population. So I have to perform the test. And see, when I run this, it generates two outputs. Like I have the statistics, and this statistic was nothing than the test statistics that I told you guys, this one. So when I run it, I have this, along with I have this p-value that I told you earlier. And the thing is, if the p-value is less than 0.05, like the level of significance, like we set like our alpha to be 0.05, that means that like it's the same thing when I say let's conduct a t-test at a 95% confidence interval. Like if now the p-value is less than 0.05, I have to reject the null hypothesis. So if the p-value is greater than 0.05, I have to accept my null hypothesis. So that's it. I have the p-value which is here, that is really less than 0.05. So we can reject the null hypothesis. What does it mean? So it means that the population, the age population for Dakar, the age population for Dakar, the age population voters for Dakar, the age data for voters in Dakar is really, the mean of that is really different from the mean of the entire population. So that's what it means. So that means that maybe we don't have the same mean, or the sample does not come from the same distribution as the population. So let's now do a sample, two sample t-tests. In two sample t-tests now, we have different samples. We have like two samples or two populations. And we want to see if they have the same mean, or if maybe the means are different. So a two sample t-test investigates whether the means of two independent data samples, you see two independent data samples differ from one another. In a two sample test, the null hypothesis is that the means of both groups are the same. Like that is the null hypothesis. The claim of the null hypothesis is that the mean of the two samples are the same. And unlike the one sample test, you just test against the population mean, the population parameters, like one population parameters. But here you have the two means, and you just, the null hypothesis says, okay, the two means are the same. And the alternative hypothesis said, no, they are not the same. So the data I've generated here, I have generated data for the entire population, and here for the for Dakar only. So I just create another sample for another city in Senegal called Kaolack that have do the same. Also, this is another sample, and this is the mean of this sample. Now I want now to compare this sample of Kaolack and the sample of Dakar. You see that now I'm out of the population. I'm comparing like two samples, and these two samples are really not the same. So what I'm doing is to use this function called start.ttest underscore independent. That is like two sample t-test. Like we are comparing two independent data samples. So inside this function, I will just put the two samples that I want to compare. That's all. So it's very easy. So I write down this function, and inside as argument, I just put the two samples, and I set the equal variance false. They are not the same variance, for example. So when I run this code, it gives me these values. I have the t-test, and I have the population, the p-value, which is 0.09. So that means that like the p-value is greater than 0.05. what do we do is we have to accept the null hypothesis. That is what I have to say. If we were using like a 95 confidence level, we would fail to reject the null hypothesis. So here we cannot reject the null hypothesis because the p-value is greater than the corresponding significant level. And the corresponding significant level for 95% of confidence interval is like 5%. So I'm sorry, you guys, that firstly, I did not introduce the notion of confidence interval, but it's not something like complicated. You can try to do some Google search and to explore more about confidence interval, or if you have time, we can still have a session for just confidence interval, but it's not like something difficult. You guys, you can try to check to see, because here I'm just talking about confidence interval. You might get confused, but it is not something like difficult to understand. So I'm sorry for that we did not cover first confidence interval, but feel free to reach out anytime you need more explanation about confidence interval, or you can just try to do some Google search. So this is like basically the conclusion of this test. So the p-value is greater than the 0.5, the significant level. So we just conclude that we fail to reject the null hypothesis. That means we have to accept the null hypothesis. Also, I have to maybe highlight something. Rejecting the null hypothesis does not mean that we have automatically to accept the null hypothesis, the alternative hypothesis. So it depends. So basically, we based on like the claim on the null hypothesis. Either we reject or we fail. So, but rejecting the null hypothesis does not like implies that we have to automatically accept the alternative hypothesis. Like, for example, let me give you an example. You have a population, you have drawn a sample from the population, and you perform some hypothesis testing, and you realize that the population, the sample does not come from the same distribution as the population. Means maybe our sample cannot describe very well my population, and I should have a sample that is really representative, that could really describe my population. So what you do is, it's not like you have just to accept the alternative hypothesis. You can go back and resample again. You see, you can go back and resample again till maybe you get a very good sample population, from where now you can conduct whatever you want to do. So, okay. So now let us do some example in population proportion. Here, we just like population means. Let us do some example in a population proportions. Like in terms of means, like here we are talking in terms of proportions. Okay, let us consider this research question. Is there a significant difference between the population proportion of parents of Black children and parents of Hispanic children who report that their child has had some swimming lessons? You see, so here our parameters of interest are the proportions. P1 is the proportions of the parents of Black children, and P2 is the proportions of the parents of Hispanic children. And you can see, for example, the data here. We have 247 parents of Black children, and this is the proportion that is given for this particular case. And here we have, this is 308 parents of Hispanic children, and this is the proportion that is given. So P1 is just 36.8%, and P2 is 38.9%. These are our proportions. Like the null hypothesis said, the two proportions are equal, and the alternatives hypothesis said no, they are not equal. Like P1 minus P2 is different from 0, or like just P1 is different from P2. So let's conduct two sample t-tests to see. You realize that here I want to compare two different things. You see, using this thing still, like I have this is the total number of parent of Black children, and this is the proportion. This is the total number of Hispanic children, and this is the proportion. So I have I simulate this based on this proportion, and this the number of like parents. I've simulated binomial distribution based on that. So I have like P1 and N1 and P2 and N1, and here I just have one line. I have to do it at once, right? So let me run this comment line. I have this now, these two populations, like, or these two samples, and I'm performing a hypothesis testing based like of these two samples to see if there is something similar or not, if the proportions are similar or not. So from sm.start.ttest underscore int, I have population 1 and population 2. That's all. And just you have to run this comment. Look at this is the t-test, this is the p-value. So first, when I run it, I have to p-value something like that, but still the p-value is 0.0656, something like that, like is greater than 0.05. So here we cannot reject the null hypothesis that says that the population proportions are not statistically significant. So means here we have to accept the null hypothesis saying that the two population proportions are the same here. You see, here I have like a p-value that is greater than 0.05, I have to accept the null hypothesis. That means the two proportions are like equal. And you can see from here, the two proportions like they're a bit different, like they're not really equal. But when we conduct a hypothesis testing, it says that statistically the two proportions are equal. So here, still the same example. I just increase the number of people. Like first here I have 247 black parents of black children, but here I have now 5,000. Also for Hispanic children I have 5,000, and I do the same and I compute my t-test. And here you see that now the p-value is really less than 0.5. That means that we have to reject the null hypothesis. And why I have done this, you realize that with the same example, when I increase the number of elements, I realize that the p-value becomes smaller, and I have to reject the null hypothesis. That takes me to z-test. Why? Because you might see that z-test and t-test are similar, but the thing is, z-test is if the sample is higher, like if you have, for example, more than 30 and something like that. If you have a very big sample, most of the time we use z-test. So t-test is mostly we mostly use t-test when we have small sample. So that's why here you realize that when I compute when I increase the sample, I realize that I have to reject the null hypothesis. So basically, this is all about t-test. You have one sample t-test, you have two sample t-test. So let me start z-test. Now, what is z-test? A z-test is a statistical test used to determine whether two population means are different when the variance are known and the sample size is large. You see what I was talking about. So most of the time, it assumes that the variance are known, and most of the time that if you have a very large sample, you just think of z-test, not t-test. So as well for z-test, we have one sample z-test and two sample z-test. So what is one sample z-test? The one sample z-test is used to test whether the mean of the population is greater than, less than, or not equal to a specific value. So we have a mean of a population and we set a value. Like we have to now test if the mean of our population is equal to that value we set or if not. So let's consider this research question. Let's say that a cartwheeling competition was organized for some adults, and the data looks like this. So we have this. This is the cartwheel distance. These numbers that you are seeing here. So the question is that, is the average cartwheel distance in inches for adults more than 80 inches? So we don't know. That means that the mu, we are asking if the mean of this, the mu, is equal to 80 inches. So we have this. This is the null hypothesis. It assumes that it's equal, like the mu is equal to 80 inches. But the alternative hypothesis said no. So this data, this is the standard deviation and the mean. You can know it directly from here. So let me just convert this thing into NumPy array, and I have this. When I compute standard deviation. This is the total number of elements that I have. This is the mean. You can see that the mean here. I have it here, and this is the standard deviation that I have here. So this is the thing. So now let me just do a z-test. A z-test is that I have my data. The data is here. I have the value. Like I said, if the mean is equal to 80 inches or not. So I just set my data and I just specify the data, and I have to put this argument like larger, alternative larger. Why alternative larger? Because the alternative hypothesis, I said mu is greater than 80, so it's larger than 80. So that's why I said this argument to be like alternative is equal to larger. So let me just complete this. Still the same, I have the t-test and I have the z value. So what is the conclusion of this test? So since the p-value is lower than the standard confidence level, which is 0.05, so we can reject the null hypothesis that the mean cutting distance for adults is not equal. So that means that we can reject this null hypothesis, like the mu of the cut-well distance is not really equal to 80 inches. So this is all for this recent question, and I hope you understand this very well. So let us move on to difference in population means using z-test. Here I have considered this Manis data, where you have a body mass index for male and female. So the question is that, is the body mass index for men and female are the same? And we don't know for now. Let's conduct hypothesis testing. So here our population or parameters of interest are just mu and into body mass indexes, like for men and for female. The null hypothesis saying that the mu, the body mass index mu1 for male maybe is equal to the body mass index for female, and the alternative hypothesis said they are not equal. So let's do this. Are like the thing like the total number of females, these are the mean, and these are the standard deviations. Then we can know it from here. You can just load this data using this cube. So you have this data here. So here I have just from the body mass index, so I have to extract female and male. So this is I have to extract the female to separate the females and the male, and from the body mass index, I will know the mean of the body mass index for female and the mean of body mass index for men here in the following code. So here is the total number of like females, and here is the mean and the standard deviation of the body mass index for females. So I have this. So this is the same thing that you had here for female, and I do the same for male. I do the same for male. Now that I have to perform, I have all these results, like, but based on this only, I cannot say like cannot conclude that the two body mass index are the same. So I have to perform a z-test using this function sm.stats.z-test, and inside my argument I have the body mass index for female. I just here drop NA because I don't want to have missing values inside. Also, the second argument here, I have the body mass index for male, and just I have dropped the missing values, and the alternative here I have two-sided because my alternative hypothesis is just like it's different. It's not like only greater or less than, so it's two-sided. So I have to specify that, and I just compute this hypothesis testing, and it generates two values, the t-test and the p-value. You see that the p-value here is very, very small. So the conclusion is that, like, since the p-value is extremely small, we can reject the null hypothesis that saying that the mean of the body mass index of female is the same as the mean of the body mass index for female. So we cannot accept this null hypothesis because the p-value is really less than 0.5, the level of significance. So we have to reject this hypothesis saying that the two body mass index for male and for female are the same. So these are basically like the two types of hypothesis testing that I have covered in this tutorial. And as I said, you guys should know that there are so many types of hypothesis testing. So you can try to do Google search and explore more about the other types of hypothesis testing. But mainly and most of the time, these are really used in real life application when we are dealing with data or and when we want to take some decisions. So these are some references. So thank you very much for your attention. So I would be very happy if you like to have any question. If you ask question, I'll be very happy to answer. So thank you very much.
Do I have question, please?
Okay.
Great. Yes, I know you have. Yeah, I know you have questions, and we'll ask your question. That's what I was going to ask you again. So please ask your question, and Mustafa will answer.
Okay.
Okay, sir, please. This hypothesis, the assignment they give to us about hypothesis testing,
Yeah.
we have not learned up to the extent that they gave us as assignment. And please, I want to know, like, what will they teach us when we enter if everything's already been taught? Now, I don't, yeah, like, it's too much now. I don't know.
Okay, I don't get your question. I don't know if Jan understand what he's trying to say.
Hey, Jesus.
No, he can come again, please.
Okay.
Come again, Emmanuel. Emmanuel, we are
Okay, I
hearing
was
you.
saying, hello, hello.
Yeah.
Okay,
Yeah.
okay,
Yes.
okay. I was asking about the assignment that was given to us about hypothesis testing. I don't know if you
Okay.
can throw a little light on it, please, on that assignment, please.
Like it's too
As
much.
Okay. Did you get it, Mustafa?
Okay. Jan, could you clarify? I still don't really get what.
It's like I will tell you if it's not that you will correct me, Emmanuel. So I think you are asking about the duration we give for the assignment, like all those assignments are going to be submitted Friday, right? Or the clarification in terms of the technique we are going to use in the assignments. Is it a
yes,
technical
this
issue or
hypothesis, yes, this hypothesis assignment, exactly. This hypothesis assignment that's going to us.
okay, two techniques?
Yes, how we are going to go about it. If you just go over it, please, today.
Oh,
Please.
okay. I think
Okay.
I will suggest you to start with some Google research and follow this tutorial. You have the notebook. Follow, look at the screen recording, and try to start. When you have a question, you can reach out Mustafa or myself. We will help
Hello, sir.
you. No
The
problem.
Hello, sir.
assignment
Yeah.
is that is it what you are talking about? Here you just like the first question somebody was just asking this morning. You have to perform some box plot, and here you have to like write the hypothesis for testing if the average weight of babies born to smoking and non-smoking mothers are different. So I think you have already like the methods. Either you try to see if you are going to use T-test or Z-test, depending on the size of the data you have. You can take the size. And here there is another hypothesis testing that you are going to perform. Whether the average weight gained by young mothers is different than the average weight gained by mature mother. And this is like uh, uh, hypothesis testing for two means. Like for two means, I have explained to you. Like you have two means. The null hypothesis says that the two average are equal, and the alternative hypothesis said no. So basically, I think maybe we can just remove this last question if it is too much for you to construct the confidence interval, as you have not yet covered this confidence interval, as I said.
Hello, Mustafa.
Yeah.
Mustafa, can I say something?
Okay, go ahead.
Okay, great. This is Victor speaking. I went through the assignment
Yeah.
and I really got stuck at the confidence interval, maybe because it wasn't really treated well in the material, and I've been researching about it, but I've really not gotten a good insight to the last question, really,
Okay,
to be
okay,
honest.
that's good. That's what I was saying, that we did not have before, like a tutorial on confidence interval. So you guys, I don't know if John will agree with me. Maybe that you can
Yes.
like skip that last question. I don't know if it's like
Uh, no, I think, guys, we are not skipping this question because if we ask the question, this is just because we have been experiencing with those kind of questions in business. Right now, hypothesis testing is very important, and the big advantage is when you are doing hypothesis testing is that when you have an entire population. Let's say, for example, you are working for a big company, and in the company, we have a lot of customers. I guess maybe about 10 million customers. And all those customers, for example, have been classified in segments or cluster. So suppose we have, for example, two segments, one and two segments. So now we would like, for example, to know if the revenue generating by the first segment is greater than the revenue generating by the second segment, or if there is the opposite situation. So now, actually, it is like more difficult to collect data from all the 10 million customers now to make to compute now the average and see some comparison and make insight. So what we do is to sample at least 30 person per segment, for example, and run the data collection from those one, and now do an hypothesis testing to compare the mean. So this is the big advantages of hypothesis testing. And now there is two kind of estimation when you are doing such kind of things. Suppose, for example, there could be like you should be asking, for example, for a task when you are going to see if the overall revenue generating by all the subscriber or all the client is equal or not to, let's say, 5,000, for example. This also is a kind of estimation. So this is a factual estimation, but when you are doing, for example, an hypothesis testing, you could be have the challenge to compute some confidence interval. The confidence interval just gives a range of from where to where your parameters should be located, and it gives also a probability. So we know that all of you are not like a statistician guy, but I request a minimal research from you before we start helping about those kind of things. We have, I think Mustafa has gone through the tutorial, and yes, I admit the confidence interval part is not, we don't have a lot of resources on that one, but all the tasks are internet open. So like you guys, I know you are very active because I was following you in the Slack channel since Monday, and to tell the truth, I'm really impressed by what you are doing. So what I ask you is to go through, and you have internet access, check things, and share your resources in the Slack public group. I know some people will come with answer, and if not, we will also come with the answer. We will not remove this question because this question is maybe going to challenge you, but if you are not challenged, you cannot learn new things. So I will let you just go through, do as you can. So you are not supposed to do everything in the right way. For the past assignment, for example, we saw people, they are not completing all the assignments, but Once we are able to see the effort we want to see in your assignments, when we are able to get the energy you are working with, when we see how you try hard, yes, we say this person could do great. Yes, and we just give you the credit to pass. Yes. So now this is what I want to tell you all. I'm really impressed by your activity, and I will suggest you to continue in this way. Try hard, get things, and try. If you fail, you try again. Once you will get the result, you will be happy by of yourself. So share your resources in the channel. If we have something to add, we will do that. If you still have some big challenges, contact Mustafa. I'm there also. Contact me. Sebastian also is there. Contact him, and I think together we will achieve. There is nothing everybody should know in Ontario. Yes, even me, I'm talking you about these things now. But if you ask me a question right now, I will probably say, give me some time. I'm going to check. Yes, so happy of how you guys are working great and hard, and I hope uh, my my talking is have made as will make you get some advance in those. So that's
Okay.
all I will say. Yes.
Okay, John, thank you very much for this clarification. So you guys should be now happy because I think the most important thing is for you guys to try. And as John said,
Yes.
when trying, you get to know more new things that you
Yes.
did not know.
Yes.
Because,
You
for
are not
example, I
supposed
did
to
not
do it.
cover,
Yes.
yeah, I did not cover confidence interval here. But when you are trying to solve that question, you will do some Google search about confidence interval, and at the end of the day, by your own, you know what is confidence interval. And this question is very important because in real life application, when you are doing data analysis, you always have to do some confidence interval. Maybe if time allows later, we can have a session on confidence interval. But I'm so sorry for not covering this like uh, in an entire tutorial. But guys,
Yes.
just go
And
and try. And you are not supposed to do everything. As I said in this morning, there is nobody here perfect in everything. So me myself, as Jan said, uh, some things that maybe I did, I have to maybe go and check again, at least for me to refresh my mind. So that's learning. So we are all learning. So you don't have to be worried, you guys.
yes. And you know, this training is not really like the one where people teach you everything from zero. You guys are already junior data scientists. So we are going to make you job ready data scientist. So this means this group is like this training session is like a small business. So suppose take it like a small company. So we have a department of data scientists, and we are going to give you just assignments. Those kind of tutorial are just to help you refreshing things. Look at, for example, if if you come new, you are a new person in the company, for example, in your first week, you could be, for example, be asked you to refresh something. They should, for example, give you, your manager will probably give you some small tasks to refresh you, to help you refresh some theory and some code and some things, how to set up your environment. So this is exactly how what we are doing. We are not teaching you everything from zero, but we are directing you. We are directing you so that we provide you with the assignment, and by trying by yourself, you are going to get the best result. Yes. So even me, if I start working new now in a company, they are going to give me some assignment. But first, I will try. I will fail. I will now look on the internet. I will get things. I will get them wrong probably the first time, and I will repeat, and I will ask some classmate or some colleague around, and now somebody will tell me something. I will try it and I will solve it. Now I'm happy. Yes. So by doing that now, a lot and many times, I will get experience it. So this is what we are expecting from you. We want you to move from your junior level to a job ready level. That means a senior data scientist, probably. Yes. So
Yeah.
feel yes. So
Thank you very much,
that's
Jan.
all.
Yeah,
Okay,
thank you
sure,
very much, Jan. So
sure.
it's really important because in the normal way, like when you are following a statistics class, for example, at university, maybe it takes you 2 or 3 months, I don't know, at least 1 month to cover all the programs. So we cannot like cover everything, but through your challenges, you will have opportunity to learn new things. So we are just giving you like the essential things, the main things you would need in solving your problems when you are in industry, especially the we make it to be more practice, not just the theory. We make it to be more practice. So I think Jan was very clear with that. Thank you very much, Jan, once again.
Yes, sure. So my people, now you have your time to work on your resources, on your tutorial. Be active, and you will achieve. So cheers. So Sebastian, will you manage the recording?
Hello.
Yes.
Hello,
Yes.
are you saying something?
Yeah, you can manage you can now stop the recording. Yes.
Okay.
Okay,
So
sure,
thank
I'll
you
do
very
that
much,
now.
guys. So
Okay.
maybe we'll have